Hi, and welcome to ConVEx 2021. I'm very pleased to be here to talk to you today about understanding the content ecosystem in order to map microcontent. Today, I'm joined by my colleague, Pei Zhu, who is an associate information architect with us here at Precision Content. She's been here with us since September 2020. And between the two of us, I'm the owner and founder of Precision Content in Toronto, Canada. And today we are looking at how do we manage relationships between content, right? So how do we create meaningful links so that we're able to link up content and manage these relationships? And in particular, I've been speaking about microcontent for many years now, but in particular, how do we link up smaller fragments of content, like below the topic level, at the microcontent level? So we've got meaningful relationships, and how do we hope to be able to automate linking within microcontent? So just to give you a little bit of background, as I said, we're Precision Content and we're based in Toronto. We have consulting, authoring, training, and publishing technologies, which we use to serve our clients. Our clients are across all sorts of different verticals across North America, fintech to high tech to pharma. And we've been in business since 2013. So today, we're looking at how we model content for automation behind linking, and looking at sort of a bit of a retrospective on content linking relationships. We're going to talk a little bit about universal information models, information behavior, and then sort of wrap up with the role of artificial intelligence in how we bring all of these pieces together. And with that, I'm going to pass the mic over to Pei.
Going to talk about the rise of microcontent. Before I start, I'd like to add Precision Content has been talking about various aspects of microcontent for several years. If you have been our audience before, we do have something new to talk about microcontent in this presentation. If you are new to microcontent, we're going to help you ease into this topic. So we do have something for everyone. So what is microcontent? You don't get microcontent by just shrinking the size of your content. Microcontent needs to be focused on one thing, one idea. Microcontent needs to be succinct, easy to scan. Microcontent needs to be labeled clearly. Microcontent needs to be written and formatted in such way that it can make sense whenever and wherever it is needed. In today's world, not only the volume of information we're consuming is becoming bigger, the content itself is getting more complex in nature. On top of this, the way information is delivered to us is becoming more diverse and more complex as well. With the advance of technologies like augmented reality, Internet of Things, and voice command, the unit of information we are consuming is becoming smaller and smaller. The rise of microcontent is in sync with this trend. The driving force behind this trend is not only technology, it is efficiency. Businesses want to bring the right information to the right audience at the right moment and right place in just the right amount, not more, not less. More efficiency way of consuming information make us more productive as workers and better consumers. In this talk, we're not going to talk about microcontent as a format of content. We're going to talk about microcontent as a medium for exchange. In every unit of microcontent, we have a piece of content that stands alone. And we have a set of metadata that is associated with that piece of content. The content and the metadata then gets automatically extracted at the time of publishing. These are the 4 principles of intelligent microcontent: focus, function, structure, and context. In today's talk, we are going to zoom in on context. Microcontent must be related to other content for it to work. There's a dilemma of linking microcontent. On the one hand, we don't want microcontent to be tied down and tightly coupled with one specific context. Microcontent needs to be mobile so that it can go to wherever it needs to be. Yet, microcontent needs to be linked to its context for it to be meaningful and useful for end users. To understand this dilemma, we need to examine 2 things. First, how information linking works and how we construct context. First, let's look back to see how information linking has evolved over time. It is not an easy task to create a system for linking information. The Gutenberg printing technology was invented in the mid-15th century, but the systematic way of organizing books and relating books from different subject matters to each other didn't happen till late 19th century. This is when Melville Dewey invented the Dewey Decimal Classification System for organizing library books. It is still the dominating organization system for libraries across the world today. The success and longevity of this organization system is because it has a unified taxonomy and it has structured, unambiguous relationship between the terms within that taxonomy. In the early days of internet, search engines were still primitive. Search engine homepages borrowed the idea of classification. They placed the hyperlinks into these neat categories to help users navigate internet. Fast forward to today, we have high-speed internet. We have the lowered cost of storage and computing power. And we have much more powerful search engine. And the result is internet is becoming a dumping ground for digital information. It is growing in size by the second. Categorizing information is becoming more difficult and is deemed unnecessary by some. Why do you need classification or categorization when you can just Google things? Internet becomes a black box. The users sees the tree or several trees that's returned to them from their search engine, but they lose the sight of the forest. People expect Google or AI to help us with this mess, but it is just an illusion because artificial intelligence cannot work without understanding meaning or context. How we create links is a part of this mess. The placement of hyperlink is largely driven by content author. The link can only lead us to destinations that is known by the content creator. Hyperlinks, especially this kind of inline hyperlinks, has no structure. It is especially hard to manage. That's the reason we see this kind of 404 pages is popping up on internet now and then. Broken links account for anywhere between 4 to 8% of all hyperlinks of Fortune 500 company websites. At the center of the problem is the mechanism of hyperlink is based on the location of resources, not meaning. It is suitable for human consumption, but not for machines. AI cannot apply logic to relationships without meaning. The delivery of microcontent is highly reliant on automation. The mechanics of hyperlink is designed without automation in mind. Therefore, this is not a suitable linking mechanism for microcontent. Linking in data has evolved and become better over the years. First, we have link and topic wrap to link topics together. Then we have cross-reference, being able to link smaller chunk of content. It's able to link to elements. Linking in data becomes more precise. And then we have relationship table. It takes related links out of content and place them in table in data map so that they can all be managed in one place. And then we have key and key wrap to introduce the mechanism of indirect linking, where redirect linking becomes much easier. We can redirect links without changing content itself. These data linking mechanisms are designed to facilitate content reuse. They are well suited for linking microcontent. However, linking in data is still based on the location of resources. As a result, the power of metadata and semantic tags that are intrinsic to data is not tapped in when linking microcontent and its content. And its context, sorry. Is there a better way to link information? What if links can be based on meaning, not based on the location of resources? What if we can link to information that we don't know existed? What if the link of information can grow automatically and organically whenever there's new information available online? All these are possible with semantic link. The idea of semantic link came from the vision of semantic web. Tim Berners-Lee, the inventor of World Wide Web, coined the term semantic web back in 1994. His idea is to transform the current document-based web into data web, where the meaning of internet data is machine readable, so that intelligent agents can do reasoning and logic and can work for human on internet. The central idea of semantic link is RDF Triple. RDF stands for Resource Definition Framework. This system describes the smallest unit of a relationship. You have three things in RDF Triple: subject, object. They are two things or two entities. And then you have predicate that defines the nature of the relationship between the two entities. To give an example, we have Picasso painted Guernica. Picasso is the subject, Guernica is the object, and painted is the predicate. This system is really simple so that it is readable by machine. The network of facts can grow out because the subject of one triple can be the subject of the next triple. And also the object of the first triple can act as the subject of still the next triple, so on and so forth. You can easily imagine this network of facts can grow automatically and indefinitely. One application of semantic linking is to have it work together to create knowledge graph. Google Knowledge Graph has the capacity of synthesizing information from a wide variety of sources that are accessible by Google. When Google Knowledge Graph is used in search engine, the search engine treats the search term not as a string, but as an entity that has relationships to facts. You Google the name Tim Berners-Lee, the result is presented as this knowledge panel on the right hand of the screen. This knowledge panel is created automatically by Knowledge Graph. It represents the most essential facts and dates that can best answer the question, who is Tim Berners-Lee? Google Knowledge Graph also provides answers for voice queries from Google Assistant and Google Home. In 2016, this technology provides answers for about 30% of all Google searches. And I suspect the number today is much higher than this. With the help of AI, Semantic Link can make data into intelligent content. And this is how it works. First, you have the content writer pull out a data document from CCMS into XML editor, which has a plugin interface to the taxonomy management system that is supported by AI. The AI then can go into XML editor and start analyzing the text in real time while the writer is working on the document. It then can apply semantic tags to the content. The writer can exercise editorial power to either accept or reject the tags. We then have this data with this added new semantic tags. This document can then be stored back into CCMS. Because these newly added tags are machine readable, AI algorithm can work on these tags to form new relationships, to apply logic. They can create knowledge graph out of this data document. And with knowledge graph, we can have all these wonderful things such as new business insight, personalized search result, smart content recommendation. As we can see in this system, with hyperlink, we no longer have the problem of tight linking or tight coupling between the content and its context. It seems to be a perfect picture. However, there's something still missing. What is missing? So I will pass over to Rob to piece the puzzles together.
Thanks, Pei, for walking us through a bit of a retrospective on linking. So, what is missing, right? And how can we do a better job at providing more context to content? So we talked about how we can use AI to surface information about topics in real time as the content's being authored, or post-authoring through semantic enrichment to really understand what content is about what. But is that enough context to make something like microcontent work effectively? So as Pei so rightly said, there really is a dilemma that we need to be able to have content that can stand on its own. So not be so tightly coupled to its context that it doesn't make sense on its own. So this enables it to be mobile and used in multiple contexts. Yet it must also be able to connect to its original context so that we can do more to explore around a particular subject or around a particular idea. So we can't completely extract it from its original context. This is really bad. Now, as I've said in previous presentations, is that as technical writers, creating content this way, or we're creating content for traditional channels and able to leverage that content to generate micro content, we're able to extract a lot of context just from the source, right from the book maps and topics and CCMS level metadata. There's a lot of metadata that we can collect and wrap up with our fragments of micro content from that content. So we burst that content and then we wrap the content in metadata to provide additional context. Again, is this enough? It's a lot, but is it enough to really make for an intelligent system? So we've got sort of book and traditional metadata about the product, the version, the date, who approved it, all the sort of metadata about that content that can be wrapped up in each of these chunks of metadata. But then we need something more. And one of the things Pei walked us through is the idea of a universal model of the Dewey Decimal System and other universal models that we can leverage to help create this sort of upper level taxonomy or upper ontology that we can use to organize content. And schema.org and knowledge graphs are all part of making that work. And it really focuses on subject, but we need something a little bit more. We want to be able to look at providing content through user intent. So how do we do that? So a number of years ago, I worked with the Ditto Oasis subcommittee, the Enterprise Business Document subcommittee. And we were looking at how we expand DITA to the enterprise. How are we going to help other departments within our companies jump onto the CCMS, onto the DITA model to contribute content and leverage the strength of the content that we've been building within our tech pub departments. So part of what I did as part of that subcommittee was start to examine other models that are in the wild, and surprised to find that there were not a lot of really useful models that we could work from. All right, so we looked at things such as the Zachman framework. We looked at mil-specs and S1000D and other sorts of structured authoring models to see what we could derive. But they all seemed just a little bit too arbitrary. So we went back to look at DITA and the origins of its model. And that's really where it sort of took us into the realm of information mapping, which was first developed back in the 1960s at Harvard by Robert Horn. And so he developed this method to categorize logical information into specific information types and organize them into a sort of a topic-based or block-based organization system. Where they defined originally 7 different types of information, but more recently looking at, fact, principle, procedure, process, etc., to organize that information. And this is really, in part, what data came out of, all right? So where we have concept, task, and reference, all right? And so, of course, when we look at the original data model, we know that it's really a task-based organization scheme for content, where we start with a task analysis to understand what does the user need to be able to do. And then we look to supplement that information with conceptual information and reference information to provide a little additional or more additional context for the user to be able to perform those necessary tasks. And that's really at the heart of what data was and how it was originally envisioned when it was released. Of course, it's grown to be used in all sorts of other contexts beyond a simple user assistance model and beyond just task-based information. But it still, it has those basic pieces of task, concept, and reference, and the idea of modeling information for intent, right? So at Precision Content, we've been working on really pressing this model, moving this model forward, and we've developed a writing methodology based on intent, and that's really where we believe that microcontent has a major role to play. So understanding intent and understanding behaviors of information is important. And when you say, well, behavior, information has a behavior, well, it's important to understand or acknowledge that information is really the product of an organic mind. Information is a mental construct. It doesn't exist on its own outside of the mind. Right? So when we say it's organic, what does that really mean? Well, we can look at information and look at other types of ecosystems and organisms to understand that there really are a lot of similarities between organisms within an ecosystem and information within an environment, within a corpus of content, how information interacts with other information. Right, and we see this in places where we're dealing with highly structured, oftentimes very regulated content, where making change to one piece of information prompts changes to other pieces of information, creating the notion of traceability of information. All right, so that when I create I have a bug, or I have an incident or an issue, it generates a piece of content, and that may generate a work ticket, and that work ticket may generate new code, which generates new documentation and generates new test cases and new release notes, right? Each sort of step along the way, sort of process-driven content that all links back to a single point through the nature of traceability. So understanding how these pieces relate to each other, and what, is there a universal context to understand this traceability? Right? And I believe there is. And that's really what helped us to develop what we call the enterprise content metamodel. So looking at information, its behaviors, the nature of it being traceable, modular, of course, and recursive. All right, so what does that mean? By recursive, we mean that content is, by its very nature, topic types and information types are fractal. In other words, I can look at a piece of information at sort of one level of abstraction. And when I look at it at a more granular level of abstraction, or a much larger level of abstraction, the model for that information is exactly the same. All right, so take a concept, for example, right? I describe a concept, and within that concept, there are other concepts that are embedded within that concept. And I dig down through a concept, and I go into a more granular, more detailed concept, and I can burrow down and I can come back up, but the structure of concept remains the same. no matter what sort of level of abstraction I'm at. Tasks, same thing, right? A task is really a step in a larger context, a larger level of abstraction, and vice versa, right? So I can drill down through a step, through substeps, through substeps, through substeps, and the structures are all exactly the same. That's the recursive nature of this type of information. So this is why I describe our content as existing within an ecosystem. It's amazing, this organic information, our mind, it's amazing the things that our brains can do with information, the connections it makes, the way it organizes information. And then we go about as technical writers to try to organize that information into electronic text, into XML and what have you. And so much is lost between trying to organize information into a written word and how organization is actually managed in our heads. So the more we can study and look at the very organic nature of information and replicate that organic nature of information, I think the closer we get to being able to automate information and make information truly accessible. So I'm going to have a look now at the enterprise content metamodel and its origins. So we start with just looking at this standard data model of concept, task, and reference. And we've already seen how there's an implied relationship there where sort of concept begets task begets reference. All right, so in many data environments, we see where we introduce a concept, a topic through a concept, and then we provide task-based information, and then supplementary reference information to support those tasks. But if we want to take a step back and we start to add other types of information, these relationships start to become more obvious. So here are the 5 precision content PC data information types. So we've added in principle and process. And we start to see how one impacts another. All right. So in this particular case, concepts provide context for principles or rules. And those rules provide limits on tasks. Right. And the nature of these relationships means that, well, changing a task isn't going to change the rule, but changing the rule is going to change the task. So follow along with me, and I'll walk through this in a little bit more detail. So when we look at a more enterprise level of content, we expand it out to 11 different types of information, each with its own type of relationship that sort of describes the natural traceability of this information. And this is a model by which we're able to identify new types of information at sort of a granular level that we can sort of say these are objects of microcontent or topic level type content because of the nature of how it interacts with other information in the ecosystem. So what's interesting for me about this is how this really breaks down into the standard human interrogatories of who, what, how, why, and even when and where. All right, so these different types of information really organize across these 6 standard human interrogatories, right, to help us better classify information. So what I'm going to do now is I'm going to take you through each one of these sort of categories of information and describe the relationships in a little bit more detail. So let's start with the who. The who are the human capital. So we start with a process, which describes something that needs to be performed. And to perform it, we have resources. So we have people who perform processes. And we can call these resources out. So a resource could be a person, it could be a role, it could be a persona, it could be a group of people, it could be a department, it could be any sort of level of abstraction of person, real or imagined, if you will. Right? So, but anyway, to perform a process, we need somebody to perform that process. And to perform a process, oftentimes we have required or requisite abilities that are required to perform that process properly. And of course, resources have to possess those abilities. So resources possess abilities and resources perform processes. Processes require abilities. So this is a basic relationship describing the human capital of how things work, how we perform our jobs, how we perform tasks within an organization. Next, we have the what. All right, so starting here just from a basic reference type topic, which basically describes the specifications for a tool and its benefits and features, as an example. Design describes how the tool works. And then above that, we have requirements that informs or governs design. And then, of course, requirements define or align with the specifications of the reference. All right, so in this case, I have a requirement and it impacts, if I change the requirement, I have to change the design. If I change the design, that doesn't change the requirement, right? Changing the design will affect the specification of the product, but not the other way around. So hopefully you're starting to see the sort of nature of this traceability of these relationships. And this is a fairly sort of standard type of relationship between information in product development. Let's look at operations. This is where we live as technical writers most often, is living in the operations. All right, starting, of course, with task-based information. So a task describes how to do something. And interesting, of course, when I perform a task, I get an event, I get a result. All right, and so a task, every time I perform it, I may get a slightly different result, as opposed to the result in the task, which is not really the actual result of the task, but the expected result of the task. So a task produces an event, and a principle or a rule or warning, caution, admonition limits the task. And above that, we have concept, which informs the principle, providing meaning to the words that we put into action with the principle or governance piece of information. And then process and reference both tie back into task. All right, so task becomes sort of a nexus for these models where information comes together, where a process needs to be performed and it's performed using a task. Tasks use tools, i.e. via the reference or the specification. So they'll consume these informations, or they'll be linked to these information naturally in the environment. And then the why. All right, we start with objectives, which really describes a need or a goal to be achieved. We have concept, again, which the concept terms inform those objectives. Objectives or needs produce requirements. And then objectives deploy resources, and resources have objectives. Okay, so goals and objectives that your department may have, or an individual may have, or that an objective says, I'm creating a new department in order to achieve some objective. So it's a bi-directional relationship there between resource and objective. So what I'm hoping to show you here is, again, it's a meta model. All right, so each one of these 11 different categories, there'll be other sort of direct specializations of these types of information, but by and large, the relationships between these different types of information remain more or less the same. It doesn't mean I can't relate to something outside of the immediacy of the model and these relationships, but it helps me to inform an automated system or automation what types of relationships I'm looking for. If I can understand the intent of information, I can understand the subject of the information, then I can understand what other related information is more pertinent. I can prioritize and organize these links and return these links better to help thread information together in the form of conversations or continued interactions between man and machine. through voice interface or through chatbot, we can create better relationships to this information to sort of feed those real human type of experiences, those better human experiences. Because of course, information is what information does. And one of the things we didn't get into too much today was about the function of information. But marrying the function with the context, with the subject, is really what makes conversational user interfaces work. All right, so being able to take the intent of the information, all right, and break it out, understanding the intent, I then am able to generate questions that align with that intent. So just knowing the intent alone, I can start to formulate a question. But of course, I can't complete the formulation of that question without knowing what the subject was. So that's where the sort of semantic linking and that the nature of using tools that can go through and understand and tag content for its meaning, that we can align with intent to create fully formed questions. All right, that then really it becomes easier for AI, artificial intelligence, natural language processing to be able to align a question with an answer, which is really key to developing content for this omni-channel world, where we need to take this content, this micro-content, wrap it in metadata, provide a lot of different context to this information so I can relate this metadata or this micro-content to other pieces of micro-content to string along these user experiences through artificial and AR, augmented reality, virtual reality, voice, chat, and the like. Micro-content really is a key part to all of this. And while it seems abstract, it really is the next step in the evolution of how we author our content and how we manage that content support, omni-channel delivery. Really, really driven by the nature of interacting with artificial intelligence. Because the robots are coming, and we can either learn how to write for both bots and humans or miss out on a transformational opportunity. Do you speak robot? I want to thank you today for joining us. I hope you've found some value in what I've had to say here. Of course, the slide deck will be available for download, and we look forward to meeting you at ConVEx, where we can answer any of your questions and sort of go down a rabbit hole or two if you want to sort of explore more about this particular subject, which I hope you find as fascinating as I do. So again, I want to thank you all for listening, and we'll see you in just a few weeks. Thank you.